Have you ever wondered how to measure flow rate with a DP transmitter? Flow rate measurement is a critical aspect of many engineering fields, and one common method involves using a differential pressure transmitter, also known as a DP transmitter. This device is strategically placed across an obstruction, typically an orifice plate within a pipe. As the fluid flow varies through the pipe, the orifice plate causes a differential pressure drop across itself. This pressure drop is not a random occurrence, but a calculated reaction to the changing flow within the pipe. It's a clever system, isn't it? However, it's not as straightforward as it seems. The differential pressure across the orifice isn't proportional to the flow rate. No, it's proportional to the square of the flow rate. So, to measure flow rate, we need a DP transmitter and an obstruction such as an orifice plate. But there's more to this process. Stay tuned to find out more. Now, here's where it gets a little tricky. The differential pressure is proportional to the square of the flow rate. That doesn't give us a straightforward measurement, does it? You see, the relationship between the differential pressure across an orifice and the flow rate passing through it isn't a simple linear one. Instead, the differential pressure is proportional to the square of the flow rate. This means that if the flow rate doubles, the differential pressure doesn't just double, it quadruples. It's a bit like trying to predict how much a balloon will inflate based on how much air you're pumping into it. The more air, the faster it expands, but not in a direct 1-to-1 ratio. So how do we make sense of this? Enter the Square Root Extractor. This handy device takes the square root of the differential pressure, transforming the nonlinear relationship into a linear one. Now, when the flow rate doubles, the square root of the differential pressure also doubles, making it much easier to measure. The Square Root Extractor can either be built into the differential pressure transmitter, or it can be a separate signal conditioning instrument. Regardless of its physical location, its role in the process is crucial. The Square Root Extractor is a crucial component in our flow rate measurement setup. It helps us navigate the nonlinear relationship between flow rate and differential pressure. Remember how we said that differential pressure is proportional to the square of the flow rate? Let's dive deeper into that. The equation that governs this relationship is quite straightforward. Here, Q represents the flow rate, and delta P denotes the differential pressure across the orifice. Now, let's put this equation to work to better understand it. Imagine we have a flow rate of 90%. Using our equation, this would yield a differential pressure of 81%. This is due to the fact that the square of 90%, or 0.9, is 0.81, or 81%. The mathematics here is simple, yet it's crucial in understanding the relationship between the flow rate and differential pressure. However, what if we want to make the flow rate directly proportional to the differential pressure? Well, that's where we'd need to do a little tweaking of our equation. By removing the square root from our equation, we can make that happen. This might seem like a minor adjustment, but it can significantly simplify the process of measuring flow rate in certain scenarios. So, by understanding this equation, we can effectively measure flow rate using a DP transmitter. This knowledge is not just theoretical, but it's instrumental in the field of engineering and beyond. Remember, the key to mastering any complex concept is breaking it down into its simplest components. Now that we have broken down the process, let's summarize what we've learned. The journey begins with a differential pressure transmitter, or a DP transmitter, placed across an obstruction such as an orifice plate. This setup creates a differential pressure that varies as the flow through the pipe changes. However, this differential pressure does not directly correlate with the flow rate. It's actually proportional to the square of the flow rate. This is where the Square Root Extractor comes into play. It's essential in applications like these because it extracts the square root of the differential pressure, making the flow rate directly proportional to this value. To put it simply, the Square Root Extractor is the mathematical magician that deciphers the flow rate measurement equation. And that's how you measure flow rate with a DP transmitter. It may seem complex at first, but once you understand the basics, it's a straightforward process. Thanks for watching.